Hello, this is Miss Nichols, and today I'm not in school, so I want to walk you guys through an activity that I would have done if I was there, and I'm hoping that you guys will use all the resources available to you, including this video and your friends, to figure out how to do the assignment. What you'll need today are Chromebook, and you'll also need a pen or pencil and the worksheet um, that your sub should be able to hand out to you. So have those things in front of you before you get going. We got to kind of different places in period 7 and period 8. So if some of this is review for you, that's fine. Just watch it and refresh your memory. And if this is not review for you, feel free to pause it so that you can keep up on your own computer. So the first thing is that everybody needs to make a copy of the data, their own copy of the data. You've got to make sure you're not working in the class data or it's going to be a problem. So go ahead and open up the home page of our Canvas classroom and click on the data link right there. It's going to open up this Nichols 2021 movement data. And inside this tab, you will see 3 different tabs for period 4, period 7, and period 8. You want to select the correct period. So right now I'm in period 4. I'm going to go through the data for period 4, but you should be in your own class. So your data should look similar to this, but not quite the same. So the first thing that you're going to do is we're going to be making a graph that has multiple trend lines on it. The way you do that is you need to set up your data so it has one column that's all of your X data, and then a different column for each series or each set of different Y data that you're going to want to project in your graph. So I kind of set up the table so that that would be the default this way. That's why it looks kind of funny. But it should work hopefully pretty quickly and easily with the way we have it set up. So what you're going to do is you're going to select all of those columns, all of the first 4 columns. The easiest way to do that is to click on the A and drag to the D directly. But if you're having a hard time with that, you can also click on A and then hold Control while you click B and C and D, and that will select all the columns for you. From here, you are going to click on Insert and Chart to put a new chart into your Google Sheet. Chart is another name for graph. And we in physics always use scatter charts. For some reason, it defaults to a column chart. So the first thing you need to go do is to go into the chart type and click on that and change it. Scroll down until you find scatter. Now, hopefully, that's going to make everything come out pretty similarly to mine based on the way the data was set up. But you can always go and double check to make sure that you have the right things in your x-axis and your series. So my x-axis should have the time data. If for some reason it didn't have anything, remember the way to do that is get rid of whatever's there that's wrong and then click on Add X-axis and then this little window pane thing, and you're going to tell it where your x-axis data is. We want time on the x-axis, so we're going to click on column A or type in A:A, and that'll put time back in there. Probably you won't have to do that. Probably it did it on default. The series are the same way. You've got 3 series in there: distance running, distance walking, and distance walking backwards. Hopefully they're already in there for you default. If not, you'll need to add B:B, C:C, and D:D for your series. So hopefully your graph looks something like mine. The colors might be different, but you can see those 3 different chunks of data, and you can see that they all kind of represent lines. From here, we're going to click on the Customize tab, and we're going to go into Chart and Axis titles first. Because we have multiple series, it doesn't automatically put our axes titles on there, so we need to put these in manually. You're going to click on the Chart Title pull-down menu and select Horizontal Axis Title. And then you're going to label that horizontal axis time in seconds because we put time on our x-axis. And then you're going to click on the vertical axis title, same pull down menu, and label that as distance in meters. Those should update in real time on your graph on the left. And so now you can see that we have our axes labeled. The next thing we're going to do is go into the series pull down. And just like we often do, the key thing that we want to do here is turn on our trend line. And When you do that, you'll notice it actually puts all three trend lines on. So now you can really see the trends of those data, which is really nifty, in different colors. The last thing we're going to do, which is new, which we haven't done before, is we actually want to label those trend lines. The computer knows the equation it used to generate those trend lines, and that will save us a lot of time if we can just use the computer generated equation for those lines to learn about those lines, which we'll come back to in a minute. So the way you're going to turn that label on is underneath trend line. Once you've turned on trend line, there's this label pull down menu, and you want to click on that guy and choose use equation. Make sure you guys can see that. So label use equation, and you'll notice over here on my graph that we now have these three equations that represent those trend lines. So that's actually it as far as the graph goes. You should have a nice nifty graph right now. And we're going to now step into the analysis of this graph and these trend lines and what is the significance of all those numbers that just appeared on your screen. So please go ahead and grab the paper that you've got now. And before we get started on this worksheet, I'm going to remind you guys that most of you in your math classes have learned about common forms of equations for lines. And the most common form that probably is used in math, and certainly the most common that's used in physics, is y equals mx plus b format. So when you have an equation in y equals mx plus b format, each of those letters represents a part of the equation and also has significance on the graph. The y is going to be your dependent variable. That didn't write very well. Let's make that into my p. Dependent variable is the y. The m represents the slope of the graph. The x represents your independent variable that you put on the x-axis. And the b represents the y-intercept. Hopefully this is ringing a few bells for you guys from former math classes. So these equations that were generated by the computer are automatically in y equals mx plus b format, except that it doesn't write the y, which is a little bit annoying, but easily remedied, as you will see in a minute. So the first question on your spreadsheet says, or on the sheet that you have, says, write the equation for the distance running object in y equals mx plus b format. So all you got to do is rewrite this thing right here and put a y equals on the front. Okay, so we've got y equals, in this case, 7x, and then this is plus a negative 18.7. You can write it that way, or you can just write a minus 18.7. It's up to you. So that is the equation for this blue line right here. Well, I'm drawing red on top of it, but it's the equation for that blue line is y equals 7x minus 18.7. And since that equation is in y equals mx plus b format, each of those pieces has a significance, right? You can kind of see how they match up there, and we'll come back to those in just a minute. But everything is kind of matching up with a part of the y equals mx plus b format. And so we're going to be able to learn a lot about the motion of that object based on understanding the equation for a line. The next step, though, is going to be to rewrite this equation with real physics variables, because y and x are kind of meaningless in physics. We want variables that mean something. Now, fortunately, on our graph, we have already labeled our y variable distance. So we know that y is the same as distance. And we've labeled our x variable time. So we know that x is the same as time. So I can actually rewrite this equation, replacing the y and the x with real physics variables. So I'm going to, instead of writing y, I'm going to write d, because y is distance, equals 7. And instead of writing x, I'm going to write t. And then I'm going to write my minus 18.7. One little thing that I'm going to add to this equation before I move on is some subscripts to indicate that this is an equation specifically for runners, right? This is only equation relevant for a running object. So I'm going to add a little subscript r to show that this is the distance of a runner is equal to 7 times the time running minus 18.7. So in theory, this equation could be used anytime you want to calculate either distance of a runner if you know their time, or the time if you know the distance. So if you plug in either of these two values, you can plug in a value for D or a value for T, you can solve for the other one and learn a lot about where a person might be and when they're running. The next two questions on the worksheet ask you to identify the value of the intercept and the value of the slope and kind of the significance of those things in this equation. So we're reminded that the intercept B is this last value, this negative 18.7. So for that first, and I should have said also, like, I'm using period force data, so yours is going to look different. So don't freak out if you have a different equation than I do. Yours should be different than mine. In any case, the intercept for this thing is negative 18.7 because that's the B value on the graph. But what does that really mean? Well, an intercept is where my line crosses the y-axis, so it's sort of down here somewhere on the graph. And the significance of the intercept is that it is your y value when your x value is 0. So in other words, when time is 0, this is where the object should be. Which means that this is actually a distance value. The y-intercept is a distance value because it is the distance value when time is 0, which means I would probably write this as dr equals 18.7, and I would put units on that because it's a units of distance. So I would say negative 18.7 meters. So that's the location of the object at time equals 0. Now, was our object actually negative 18.7 meters when time started? Probably not. The reason we have a big negative intercept in this case was because my runner didn't start right when we started the stopwatch. And so we ended up, basically, this is where the runner would have been if they had been running that entire time when time started. So if I lost you right there, don't worry about it, but realize that that is where the runner should have been when time started. The last question asks you to figure out the significance of the slope, which in this case is 7. So I know that slope is 7. What does it mean? Well, hopefully you remember from our graphing exercises in class that the slope has something to do with how fast the object is going, right? The steeper the slope, the faster the object, and the shallower the slope, the slower. So the question is, like, what is the exact correlation? So if you remember from your math class, slope is equal to rise over run, right? The rise on the graph divided by the run of the graph. And so if you think about the units of the slope, they're going to have to be the units for the rise, which is meters, because that is the y-axis units, divided by the units for the run, which are seconds, because that's the x-axis units. And if you look at those units, we have meters every second, which actually is, in fact, a velocity. So the velocity of the running object is equal to the slope. And if you put units on that slope, then you can tell me right away what is the velocity of a runner. And that's really useful information because I can actually now compare the velocities of all three of these objects. I have 3 different values there. And I can use those velocity values in calculations with my velocity equations. And so this is a really useful thing to have been able to get from a graph of our data. So at this point, I'm going to ask you to, in a minute, stop the video and go ahead and complete the second 2 chunks of the first side of the worksheet. So basically do the same thing with the walker and the person that walked backwards. Figure out your equations, figure out what is your intercept, what is your slope, what is the meaning of those things. And then if you can, flip the worksheet over and see how much progress you can kind of make on the backside. There's a bunch of questions on the back, conceptual questions about what does it mean that, for example, one of these slopes is negative and the other 2 are positive. What does that mean? Can you figure out which of the walkers was going faster, the forward walker or the backward faster walker, and how do you know? Those kinds of conceptual questions. And there's also a couple mathematical challenge questions that basically say, can you use the values that you figured out from your equations before to calculate some other values? You'll want to use your motion equation. Your V average equals delta D over delta T, okay? And you can use your V averages that you're going to get from these equations, and you can use the other values that are given to you in the problem to go ahead and solve. So in any case, my challenge to you is to see how far you can get in this worksheet today on your own. Please use whatever resources are available to you with people around you and other folks that you can ask for help. And we will revisit this when I return. Thanks for watching.